Good morning, everyone. Hope you can hear me all right. Hi, Claire. Hi, Chloe.
Hello.
Let's wait a couple more minutes to see if anyone else will join. And in the meantime, please sign in the shared doc. We'll use the same Etherpad. I'll paste the link in the chat. Yeah. Also share with us if you've got a favorite plot type, or if you know of a famous example of some plot. I'll go with climate stripes. I'm sure you have seen it, this kind of blue to red gradation showing temperature anomalies. I think it represents quite well the science behind kind of climate change, but in a more accessible way. One second. So we're in the pad on around line 700, and the schedule is like yesterday. From now to 1 p.m. and we'll take a break at 11. I hope you have installed this DB browser for SQLite or SQLite, which stands for Structured Query Language, that we use to interact with databases, in particular relational databases, and I'll mention briefly what this means shortly. We will be using the data carpentry's materials. Okay. So let's open up the DB browser, and I'll briefly talk about SQL in general, and Chloe chime in if I'm saying something that's not entirely correct, because yeah, I have limited experience working with SQL, so I've taught this lesson before, but Chloe is using SQL on a regular basis, so if you've got any in-depth question, I'm sure she will be able to advise. Okay, let me share my screen. So we will be using the same data as we've been using before. But there is also a file with the ending SQLite 3, I think, in amongst all the data files that we've downloaded. Let's have another poll. If you've got the data. So this is from this Portal project dataset. I'll paste another link. So the DB browser is a GUI application, so a graphical user interface for interacting with databases, and we'll use this to get acquainted with the structured query language, and we'll see some similarities to deploy verbs from tidyverse. Okay. Okay. Yeah, let's get started and see who else will join later, perhaps. So, what's the motivation behind being acquainted with SQL or SQL? That I guess there's no standard way to pronounce it. You can pick and choose, and I'll probably slip from one to the other. Structured query language allows us to use functions such as insert, select, update, delete to create databases and interrogate them to obtain some data sets. So many data sets are stored in databases, and for large data sets, this might be the only feasible way to store those. So we will be also looking at something called relational database, and we'll see this in a moment using an example. But a relational database stores data in relations, and relations are defined through records with fields. These are roughly like observations in our data frames yesterday, and they can be represented as tables. Each record is shown as a row and fields as columns. And in many cases, we'll have something called a key or unique identifier that allows us to create relations among tables or refer to other tables. So some benefits of using relational database are more technical, as it allows for better performance for specific types of queries and for specific types of data. But it's also a mature technology that has been used for years now. Edgar Code is credited as one of the main inventors of relational databases, and he received the Turing Award for this work, which is an equivalent of Nobel Prize in computer science. Perhaps you have come across terms like MySQL, Postgres, MySQL Server, and so on. So they refer to implementations by particular vendors or groups of the standard query language. Okay, let's have a quick look at the pre-existing database. If you open up your DB browser, I hope you can see the window. Is the size all right? Okay. So we can then click Open Database and then find, so the window will pop up, which you might not see because I'm sharing the DB window, the DB browser window. But then there you choose the directory where you've got the data. So yesterday we downloaded some data and it's called portalmammals.sqlite, this file. And if I click load, it shows what tables got included. So I should also mention often SQL databases are based on special servers and we need to create a connection and so on. But for simplicity, we're working with the file database, which is located locally on our machines. Okay. Was everyone able to load this file? So we can see we've got some tabs, so we can look at the data. For various tables, we can check the structure. So this is like the metadata, big in text. This describes the types of the fields. And this way we can quickly explore a database using the graphical interface. And then we'll work in this field where we can type queries and interact with the database this way. Okay. Yeah, so begin state for big integer. We can also have floats and many other data types are defined in the SQL standard. In terms of database design, we also want to stick to similar principles like tidy data principles, so that every row column combination contains a single so-called atomic value, so that we don't need to split a complex value into parts first to work with it. And we've got one field per type of information and no redundant information. So storing things in a relation database allows us to also save some space, like save some memory. And it was more important in the past, but it's still important because some data types like movies or high resolution medical records take a lot of space, so that's still important consideration. Before we start writing our own queries, so request to the database, which the database will respond with some data or a message. Let's close the currently open database. We can do it through the file menu. And then let's use some CSV file that we also have in the data directory to create a new database from a CSV file. So if we click on new database, and then navigate to the folder where we've got the data, and then okay, let's click cancel in this window, and instead import from CSV. So we'll go this way. Import now. Sorry. Okay, let's go back a step. I missed one step. So if we go again to new database, then at the bottom we select all files. It will show also the CSV extension files. So we can give the database a name. Let's call it surveys and click save. Then there will be another pop-up where we click cancel. And then we should be able to see some information that we've got the database created, but now we need to import the CSV from. Now this should not be gray anymore. Table from CSV file, and now we can choose service CSV and click open. We will see kind of a depiction of the data. We can choose the table name surveys. And first column, we should check the box column names in the first line and click OK.
Sorry, I missed that. Where was the import from CSV?
Under file and then table from CSV. I'll post the steps into the shared doc.
Okay, perfect. And then which one are we loading? Sorry.
Surveys CSV.
Okay.
And on line 745, please let me know once you've done that. So next we can modify, click this modify table bit. And click save. Then there will be another window that appears showing the data types. and we can click OK in there. At the bottom, it will show some a command called create table. This is the actual query that will create this table. And then we should see this kind of data types for various fields up here. Already, from looking at it, we might see that some data types might not be entirely correct, but we'll see how we can work with that. I wonder if we can edit this bit now. Actually, okay, let's edit the types straight away. So we can click again onto the table and then modify table, and then we can check which types we would change. So let's maybe have hindfoot length as real. So as it contains field, like as it contains the measured data. Any other suggestions? What might be where we should change the default guest type to something else? We've got month, year, day. There could be integers. That's fine. Plot ID. So weight. How about weight? I suggest we change it to real as well. And if we click OK, we should see this has changed here. Okay, I see there's some troubles with DB browser. Which operating systems are you on? Windows? Is the screen also still frozen? Let's keep weight as real. I guess numeric would also work.
I think when you're sharing your screen, I think there's when like pop-up windows open, I think they're not coming up.
Mm-hmm.
So we can just sort of see the base screen, but not the.
Ah, okay.
I think maybe it might be you might share your screen differently.
I might need to sort of share the same thing 2 times. Or something like this. Let's see. So you just see just empty white screen, or do you see the surveys bit? the table. If I click on surveys, does it open up?
Yes, I can see that.
Okay, that's it. I've been in not doing much actually in the window. So if I click on surveys and modify table, this will open up a new dialog, and this will not be visible. But as long as you see the main window, we'll be working in the main window most of the time. So okay, let's make sure everyone got the data loaded, and then we can proceed to write some queries. So we did this with surveys. Let's also import the plots and the species table. Again, import from CSV, and now we choose the plots CSV.
I think it's now when you've got like pop-up windows, you can't see what it is you're doing on the screen kind of goes a bit darker,
Yeah.
but we can't see the buttons you're clicking. I wonder if there's a way you can like share your whole screen. I don't know what the screen sharing options are.
Yes. Okay, let me try. Okay. How about now? Now you're gonna see like my desktop icons as well. But
Yeah.
this way it should show.
So now if you go to the okay, yeah, if you go to like import table from CSV, yeah, okay, cool, that's better. We can see everything.
Okay.
Perfect. Thank you.
So we got plot species as well. So we need to click column names in first line if there are any. Click OK and we should have this. Okay, we can delete it and do it again. So here, probably shouldn't click this, or should click this. Yeah, so this is plot ID and type. I mean, there's some more options, but we'll stick with the basic import for now. So it is possible to also add new fields under modified table. All right, let's save this first, I think. So we can add new fields if we want to here, and this would create a new column. But for now, I'm not gonna do it. There are many more other data types. So let's see if I can quickly bring the browser in here. So this is a list of some of the SQL data types that are supported, and it's quite detailed. For example, there's a date type, but it might behave in some different ways to what we've seen in R. And we can also see that different kind of vendors have also different style of naming and so on. So it can get a bit complicated to get everything matched, but we'll be working with mainly with basic data types like numbers, text, and floating point numbers or reals. So what SQL allows us to do, it's a language to create queries that allows us to get subsets of the database to work on and perform some operations like calculations or combine data. And these different database management systems, or DBMSs, like Oracle or Postgres, have slightly different syntax for things, but that's something then we need to check the documentation for the system we're working with. Are there any questions so far? If not, we will go to the Execute SQL tab in the window, and here we can type the queries, and then with run them with Command Enter on Mac or Control Enter on Windows or Linux. So if we type a statement, we can use some keywords like select as a keyword, and you could see it's kind of highlighted blue. Star is a wildcard symbol, so that stands for all. And then we need to specify which database we want to use. In this case, surveys. Or did I name it differently? So if we use a different name, we could see the syntax, the highlighting has changed in the browser. This suggests this is not recognized as a database. But if we still try run it, we'll get a big red error. But it says no such table. So, but if we specify the correct table, we'll see the output below, and it will also summarize the number of rows and the timing.
Hi, we've just got a question in the chat. Are you okay to zoom in a little bit? Is it possible to zoom in?
Should be. Just need to find a way. 1 second. Okay, this is the data font. How about this? I mean, somehow this still is tiny, strange. Okay, here we can do the Control Shift plus. How about this?
That looks better, yeah.
Okay. Okay, hopefully everyone was able to run this query and then see the output. So you can run it by pressing the run button or some of the commands. Control return, for example, from me. Okay, let's have a poll. Could you paste the number of milliseconds you've got in the rows return? And you should have this 35,000 roughly rows. So we have capitalized select and from by convention, so as SQL keywords, but SQL itself is case insensitive, so we could have written it like this and it would still work. But for readability, it's recommended to have oops, somehow it's frozen for a sec. Can you still hear me? My other screen is frozen at the moment.
I can hear you okay.
Okay, I don't know what's going on. Okay, maybe the DB browser might have died. Okay, strange. Okay, I might need to relog in.
Okay, while you're doing that, I'm happy to answer some questions. Gudrun asked, which column has the milliseconds? So it's in the bottom. If you look on the screen share, there's the top window where you're writing the query, there's the middle window with the result, and then there's the bottom window that shows the result of the execution, that sort of message that comes out. So you can see there, it says 35,500 blah, 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 rows returned in, oh, screen sharing is gone. I can share mine. How do I share mine? Let's share content. Share screen, entire screen. Oh, there we go. Can you see that? Cool.
Yeah, I see. Thanks, Chloe.
Okay, awesome. Oh, I've just closed the chat. Okay, cool. Okay, cool. So yeah, so has everybody managed to get that first query running? It looks like everybody has. Is anyone having any issues with that? No? Okay, cool. Well, in that case, so as you mentioned, SQL is case insensitive, so it's kind of convention that we write these keywords in uppercase, but we can write them in lowercase as well. So this wildcard asterisk selects all of the. Oh, sorry. Can everyone see okay? I realize I've not zoomed in. Is my font size? Oh, it is quite small, isn't it? I'm going to zoom in a little bit. Oh no, now I need to work out how to zoom in. Can everyone see that? Like, is the font size okay? I'm going to try and work out. I don't know why. Control Shift under View in the bottom. Just about to say. Okay, well, hopefully I won't be screen sharing too long anyway. Hopefully the technical issues will be resolved. Okay, so this asterisk picks out all of the columns from the surveys table, but what we can also do is we can select individual columns. So for example, select month. If we run that, it picks out just the month column. We can pick out multiple columns as well. So we can pick out, select year, month, and see it gives us little autocomplete suggestions. So if we run that, you get the year, month, and day values from each row. Scroll, 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 got lots of values. So, does that make sense so far? Is everyone able to filter? Cool. Brilliant. So everyone's able to select just a few columns of interest from the table. Nice. And we can always come to the database structure tab to get a little refresher of what the different variables in our table are. So right now, what we're doing is I'll go back to select star. You run that. So now we're pulling up all of the rows and all of the columns. But sometimes, oh, welcome back. So if we don't want, sometimes we might have a really big data set and we don't want to pull up every single row. Like sometimes you're working with, hello.
Not sure what happened there.
That's okay. Is everything working okay now?
Browser crashed.
Oh dear. How about, I'll let you get set up. I'll finish this demo and then I'll pass back to you. So we're going to have a look at the limit.
Able to get the databases in from CSV. Let me see, initiate doc. Okay. Yeah, from the results we can see, because we've got different machines with different characteristics.
I'll stop sharing my screen so I can pass back.
We'll get slightly different timings. Okay, shall I try share my screen again?
Yeah, if you share your screen, it might just, yeah, I'm not sure how to stop sharing my screen, so maybe for you to start, it'll take back over. Amazing.
Okay, so we can continue looking at the syntax. So let's say if we want only the year, we can select year by column name from surveys, and this will give the years. And if we wanted to have multiple things, we will have multiple columns specified, like so. I'll copy this also every now and then into the shared doc. So we might not want to show all records. This is how we can limit, if we're only exploring the data, we can limit the number of records shown by this limit keyword. What else could we do? We might want unique values. Then we can use distinct keyword. Let's not use the limit here. We want to see all distinct possibilities. So all various species that has been observed. And we can also select multiple columns. So this might or might not be meaningful for a particular dataset combining two of the fields. So this way we could see for each year the species that were observed. We can also see some missing values. I mentioned that we can also perform calculations on the values. So this is something we can specify as part of the query. So let's remove the distinct bit again. So we specify some calculations, and the usual arithmetic operators are supported, and there are also mathematical functions. Huh. Interesting. Maybe when I needed to re-import stuff, I forgot to change the type.
Oh, just a question in the chat. Are you able to, the font size has gone down again. Are you able to zoom in again?
Oh, yeah.
Perfect.
So I would have expected to see more numbers. Yeah, okay. So if we've got missing value, then the calculation will also be null. and null stands for this kind of what we've seen as NA yesterday. So, but we've got the result elsewhere. Okay, let's do an exercise. So I think the comments, is this a SQL comment? So let's have a query that returns year, month, day, species ID, and weight in milligrams.
Sorry, how did you fix the problem with the weight column returning null?
It's not fixed. It means for some it will be null, but unfortunately all the first ones were null, so it looked like everything is null. But if you scroll down a bit, you can see there are some values in there. So milligrams stands for 1,000 grams, and the original weight is in grams. So we can spice species ID and then get some numbers. So select is quite similar to the select from tidyverse that we've seen yesterday in R. We can pick some columns. Next, let's look at ways to filter. So similarly to filter from tidyverse, in SQL we can also filter. So now let's stick with all data items from surveys, and then the new keyword here is called where, and then we can specify a restriction or a condition for filtering. For instance, if we want to select only a specific species ID and we run it, we can see the species ID field only contains the specified values. So, and we got a subset of records. So this way we can quickly explore data to check how many particular species, or for a particular field, how many values with that value we have. Oh, how many records with that value we have. Copy this into the shared doc.
Can I ask the semicolon at the end of that where statement?
Yeah, I think it's required. Although it's understand it's without, but it's a good practice to have it because of the way sometimes the statements are treated. We might end up with two statements on one line, and this will be a statement separator. So
right. Okay.
Is it correctly? Correct me if I'm wrong, but this is kind of a good style to have the semicolons.
Yeah, that's right. It's good practice. I think different different versions of SQL. Some are more fussy about the the semicolon than others. And I think it's just generally good practice for separating, separating statements. There are some types of statement that will only work if they can't. If some statements will work if they come after a semicolon, some won't. Like, I'm not sure we'll touch on those today, but just generally it's good practice to put semicolons after your statements.
And
So
we
yeah,
can
you want to
build
put
those conditions. Sorry?
Oh, sorry. I was just going to say, in response to some of the comments in the chat, you'll want to put the semicolon at the end of like the full statement, at the full block. So I think maybe what's happened is, if you're having issues, we previously had a semicolon after surveys, but then if you're writing the where statement after that, it hit an error because, yeah, that's it. So yeah, you want to make sure.
New statement starts here. After this, the new statement starts, and we cannot start statements with a where.
Yeah.
So what would work is this probably.
Yeah.
But then this is not necessary. So we can specify more complex conditions based on logical expressions, and we use and instead of ampersand sign and or instead of the bar. So if you think about yesterday when we were using filter, now and is the keyword for logical and. So we want year to be larger or equals to 2000 and species ID to be either DO or DS. So this way we can see, yeah, this sometimes changes. And the year is, here we've got the other year. This might be output from the previous run where it was everything. Or maybe the syntax is incorrect here.
Yeah, try re. Try rerunning it, or it might be something to do with how the brackets are applied.
We have to group the ors.
Yeah, that's it.
Okay, it needs to be careful. So in some programming languages, or has a lower precedence, or so the higher precedence. Sorry, so it's grouped together. But here we actually need to group this using parentheses. So it's always good to check the output if it does what you intended to do, even if it doesn't produce an error. It might still have some subtle issue. So if the condition is specified slightly incorrectly, you might still get the table and data and can work with it in the next step, but it will produce unexpected results. So this is putting a semicolon in the wrong place. This would be a syntactic error. But having parentheses placed differently might become a semantic error that a wrong condition is used. But the database engine will use the condition as long as it's syntactically correct. Okay. So there is also another notation we can use to specify kind of membership in a set of values. I'll just quickly copy this over to the shared doc. So instead of saying this or this, you remember it will be quite a long sentence if we have many values for species we want to select. So instead we can use this in notation, species ID in, and then we group together all the values that we want to check. Any questions about filtering? The next keyword can be used if we want to sort the output. So if we select from species this time, and we can use order by keyword, and we can use the taxa field, and we can specify we want an ascending order. Okay. So we got alphabetical order, and we can also choose descending order. Then it will reverse the order. Bird will come last. I think it's good practice to specify the order explicitly, but I think it will otherwise use ascending as default. Remember how we used sorting to quickly check data for anomalies, because often empty records or somehow malformed records will either bubble up to the top or drop to the bottom of a sorted set. Okay, let's have a quick exercise. We want a query that returns year, species ID, and weight in kilograms for surveys, from surveys, and sorted with largest weights at the top. I will copy this also to the shared doc, and feel free to share your solutions at line 783 and below. And we can build the query step by step. So we can start with select from surveys table. Okay, this is not a command. Okay, so to create a comment in SQL, you can write this kind of style command in /*/ everything in between that got marked green will not be part of the statement. So we can check first we got the database table from which we can read. So we got this part. So remember the weight was in grams, right? So to get in kilograms, we need to divide by 1,000. Okay, let's see if it still works. We got something. And then we need to sort, so order by. We might need to select weight and order by something like this. Are there any suggested solutions? No. Okay. Yeah, good question about null values. We can make this part of the exercise. Excluding null. Okay, let's say excluding records with missing weight values. So knowing what we know about filtering, any suggestions what we could do in the where clause?
Would where the weight is greater than 0 work?
It might do. Let's try. Looks like it did. Claire, do you know the syntax for specifically excluding null? So there might be
So
weight
to
is not null, something like
yeah,
this.
that's it. Yeah, that's exactly it. So that will exclude all null values, and that's probably the best way to do it, because there might be some values that are just 0, but that is a legitimate value, whereas if we want to exclude nulls specifically, we will use that is not null syntax.
Yeah, let's stick with this syntax for excluding null, but where is very flexible in terms of how you build this condition. This can be also using various other constraints. So we might also exclude one particular species ID, then we would add it using the logical AND and so on. in terms of like a note of ordering. So what happens is first the filtering according to where, then sorting according to order by, and then displaying of requested columns or expressions. And the clauses are written in the fixed order, like this: select, from, where, by. Okay, let's have another exercise. I'll copy this into the shared document. So next exercise is using surveys table to write a query to display 3 date fields, the species ID and the weight in kilograms. So we can reuse part of this query, and then we want to round the weight to 2 decimal places. This we can do with round function and specifying 2 digital places. I think it's like this. For individuals captured in 1999 only, so we need to restrict by a year and order by species ID. Okay, there was a question about database field types. So when we were importing the CSVs, there was a change we did. I think if you click on modify table, you can then, oh, I shouldn't do that. So pick real for weight. Yeah. Let's also keep empty weights excluded. I think it's possible in the settings to set the background to less aggressive red. for the arrow box somewhere. But this is how roughly this would look like. So we select from table where order by. Any questions about selecting, filtering, ordering, or the specification of the kind of filtering conditions? So it's useful to stick to the conventions, to have the keyword specified for readability in all capitals. We can use logical AND as well as OR to create more complex filtering conditions and more complex queries. We can perform some calculations, and there are many other functions available by default as part of SQL. And we can add comments to the queries or comment out parts of it to build query incrementally, step by step. Okay. We can also aggregate data to have summaries. If you remember, we had group by and count as part of tidyverse verbs yesterday. So similar functionality is available in SQL as well. So let's see. So we can apply aggregation function to group things together. If you remember, I briefly mentioned the split, apply, combine approach to analyzing data. So aggregation can, so group by statement can be used to combine things together. Okay. So we can count things using the count keyword or function rather. So this way, instead of relying on this kind of output of the tool to know the count, so if we just select star, we can see the count here, but this is part of this console output. But if we want to deliberately look at it, we can use the count function. Another commonly used function is sum. So if we want to see what's the total weight of all that are not null, we can apply this. And we can nest functions, so we can kind of round the results of a calculation something like this. There are other functions such as max, min, average. Okay, but what if we wanted to use to group things together? So we wanted a value not for all records, but for instance by species ID. Then we need to select count. Let's see what happens now. So we still get everything. So now we can introduce group by. And we could see for each distinct value of species, we get a count. Okay. Let's have another exercise. So I'll paste it into the chat. And then once we're done, we can have a break for half an hour. So we want 3 queries. One, to check how many individuals were counted in each year, and then how many were counted in each year for each different species, and then the average weights of each species in each year. So hopefully you can see a pattern how we can specify this groups using group by. And then for the calculation we need to apply some functions. You can round as you see fit. Okay, let's do the exercise. Also, we are on line 810 and below, so please paste your suggested solutions and we'll discuss them briefly. Okay. But we still need the group by part. So if we exchange year, species ID for year, then that's what we get. Okay, I'm sort of giving away the answer to 1, but let's have the answers to 2. And 3. They might be the same answer. So we want also how many were counted for each year for each different species. So that's species ID. And And we also group by species ID. And then we also want average weights. A little hint. Remember I mentioned AVG for average. It exists as a function, so we can use it. And if we run this, maybe we'll round it as well. And then okay, we need to give a name to this column. Maybe it's as average weight, something like this. Will this work? Okay, let's exclude the nulls using where as we did before. Alright, if this still works. Yeah. And we can order as well. I mean, now we're going beyond the specs of the exercise, but okay, that's an example query that's a bit more complex. Okay, yeah, let's take a break. And then we'll come back to look at more complex queries, and we might also have some time to look at connecting to a database from inside R, or using R Studio and R packages, such as R SQLite. There are a couple more keywords as well we'll look at, and then also joining data. Speak to you again at 11:30. Okay, there is no such keyword as back at. Welcome back, everyone. Hope you had a nice break. Let's continue this introduction to SQL. Let's briefly speak about aliasing. So we can, let's say if we select max year, from surveys, the name of the column is by default the same as the expression, but we can give it another name. Yeah, you can see it has changed here. More generally, so we can sort of rename something and sort by that. It's also possible to alias tables. So if we have a very long table name, we can create an alias for that. Okay. Let's have a look at another example of another keyword called having. This is similar to where, but we use it when we aggregate. If we select species ID, and let's count by species ID from the service database table, sorry, group by of species ID. So now this is the new keyword. We can say we drop all results that let's say smaller than 50. Okay, let me try this. Yeah, so that's maybe a bit nice to write. So instead of rewriting the expression that was used, we can rename the column and then use that in the condition. I'll copy this into the shared doc. We're at the very bottom. Oh yeah, there are some other examples for renaming there. Thanks, Clay. So those are using this bracket notation. So I'll copy paste one of the examples from the shared doc to show this renaming, so we could see it's a shorthand. So we can use square brackets and define the new name, and then you can see the name has changed. And here's an example of a where clause with multiple kind of exclusion statements. So we want both. Actually, this will exclude, I think. Will this exclude both, or will it exclude the ones that are both nulls? We can see we don't have weights that are null. Any questions about this group by aggregating using group by or the as aliasing? Okay, let's have a quick exercise. So we want from species table the number of species in each tax only for those that have more than 10. So we will need to use okay, and use the aliasing. So and count column should be called n without the tick marks. So just n, yeah. Let's spend a few more minutes on this. Feel free to share your suggestions for solutions, and we'll discuss shortly. We are on line 855 and below in the shared document. Okay, let's see. From the species in each tax. Or we could say as n here as well. From species group by Yeah, so having specifies this condition that the count should be larger than 10, and we see rabbits and reptiles are excluded because of that. Brief mention, for convenience, we can store queries for future use, using views functionality. Okay, 1 second. Okay, my browser might have frozen again. Okay, I might disappear for a moment.
Yep.
Cool. Okay, good. Okay, yeah. So while technical issues are being resolved, if anyone has any questions, just let me know. Feel free to pop any results that you've got from your queries into the shared document. And if I'll pop a little poll in the shared document as well to check if people have done this, because if everybody's done, then we can move on. Okay, so that looks like a lot of people have completed the exercise. What results have people got? What are the taxa that you can see?
I've got 13 birds and 31 rodents.
Lovely. Yeah, that's exactly it. And so just a question, what happens if you take away the having statement? What do you see then?
We can see rabbits and reptiles as well, which have accounted less than 10.
Exactly. So yeah, that's just a nice little check to see that our filtering is working. So yeah, cool. Okay. So if everyone has done that, any questions before we move on? No.
Everyone, sorry. Somehow everything crashed again.
Okay, I'll pass back to you. We were just talking over the results of that aggregate exercise.
Mm-hmm.
Yeah.
Actually, I have a question. Is there an undo button to if you've deleted a line to put it back in?
Control Z might work, or Command Z as a key command.
Yeah, that works. Thanks. Yeah.
Okay, in the interest of time, I will sort of go through materials, but not in the DB browser, just to look at the syntax for a few more things, and then jump into R. Let me share my screen. I feel like if I share the whole screen, this is when the crashes are more likely. So I'll stick to a single window now. One second. So hopefully you can see the browser window.
Yep.
So we've looked at group by and count, and I'd encourage you to have a look. We skipped a couple of exercises from the materials to save some time, but it's good to practice. So we've seen the having keyword. When we use group by, we also can use having, and to create these filtering conditions, similar to the where keyword. So what I mentioned by saving queries for future use, we can create a view. So we can give a name to our query, and this will act as a table for the purposes of selection. So if we have a query, and then we prepend create view, and then we can give it a name, and the as introduces the query itself. So then later on we can reuse this view as if it was a table. So we can create a small subset, for example, of our data and then run analysis queries on that. So we have covered null value. So some functions might just ignore it, some might treat it as 0. So it's best to exclude it from the data before applying functions to that. And last thing is to look at combining data. So this is a very brief kind of introduction to what a join is and this join clause. Let me scroll down for a moment. So if we have multiple tables and we want to combine them together, we can do this using this join syntax. And there's some much more complications in this than we can cover today. But this is the idea. So commonly used joining styles are inner join or left join, which are if A and B represent tables, we can use this key, some field as a key to join on. So this must be present in both tables. So A.key equals B.key. This means those records will be selected for which the keys are present in both tables. For an inner join, so we've got a subset. This is in terms of this Venn diagrams, it's an intersection. And left join selects focusing on one of the tables. So you could try a statement like this. I will put it into the shared doc. So join is the special keyword, and another keyword is on, and then you specify the keys. For instance, we can use species ID as a key in service and species. I'll just stop sharing for now. I'll try get back into the DB browser once more. One second, I'll briefly re-import from CSV. Okay.
So to answer Paul's question in the chat, the behavior of the join, if there's no matching value, depends on the type of join that you're using. So to go back to the Venn diagram, let's see if I can post that Venn diagram picture in the document. Using an, I'll just pop this into the thing. Can I put an image in there? Maybe I can't put an image in there. Oh well, that's okay. Well, actually, is it right if I just share my screen really quickly?
Yeah, sure.
Yeah. Okay. Just to explain this. Oh no, I don't want to share a whiteboard. Sorry, I didn't do that. Share screen. There we go. Result of the join. Okay. So if you're using an inner join, which in this case you're using join is an inner join, the results in your output will be the rows that appear in both A and B. So if there's species IDs that appear in A but not B, they won't come up as the output. Only the species IDs that appear in both A and B will appear in the output, and then the corresponding rows associated with those IDs. Whereas if you use a left join, if there's a species ID that appears in A but not B, it will be included, because the way the left join works is it pulls up all of the values, all of the rows from table A, but only the rows from table B that match up with those in A. So you're getting all of the data from table A and the data from table B that matches up with table A. Does that answer your question, Paul?
Yeah, I think that makes sense. So would you just see a null value if?
Yes, you would. Yeah.
Just say, yeah.
Yeah.
Okay, that's great. Thanks.
Oh wait, so sorry, wait. So no, actually, if you were doing a left join, the values that are missing from B will show up as nulls. Whereas if you're doing, how am I trying to describe this? I think if you're doing an inner join, the rows won't show up at all if they don't, if the A's and B, if the A key and B key don't match.
Yeah.
Yeah. Does that make sense?
I think so, but on the left join, it's pulling all the rows from A.
Yeah.
And if there's not a match in B, the row's still going to be there, but the data from B just won't appear.
Yeah, that's it. Yeah. So like all of the columns from table A will contain data, but then the columns from table B will be null because there isn't that. Yeah.
Okay. Yeah, I understand. Thanks.
Cool. No worries. So Andrew, the result of the join is to append columns from species to surveys. Yes, that's it, exactly. So you're going to get all of the columns from species and all of the columns from surveys, and yeah, you're joining on that column species ID. Cool. Right, I'll stop sharing my screen.
Yeah, let's do one exercise on joins. To combine it with sorting and aggregation, I'll paste it into the shared doc. We're on line 877. Or let's go with 874 and we use the poll after that. So once you complete the exercise, let's use the poll to refer to this exercise. So to write the query that returns the number of animals caught of each genus in each plot. We also want to order the results by plot number in ascending order and by descending number of individuals in each plot. If you've got suggestions for solution or code we can discuss, pop it into the shared document. So the rough structure will be as follows. We could say using species ID as a shorthand for on service species IDs and species IDs. But this requires the columns for the keys to have the same column name. So if we think about the figure, A will be surveys and B will be species. We use species ID to join on as a key. Okay, we need number of animals.
You're not sharing screen at the moment.
Okay. Yeah, I can show like rough structure of the code, but that's kind of an individual exercise, and let's spend say 4 more minutes on it. The exercise is in the shared doc. So this will be the rough structure. So select, from, join, using. This can also be on survey species ID equals species ID. In each plot. So we need to think about where plot ID comes from. And genus. The number suggests there is counting involved. Let's call it number individuals, like in div. So we can see plot ID is in the surveys table, and genus is in the species table. And this is how we refer to them using the dot notation. And we group by both. So I'm sort of translating the English description bit by bit into the SQL syntax. Here the number refers to ID of a plot rather than some sort of count. Number individuals we've got up here. Huh. Don't know whether it's disliking the using syntax. I think I forgot the semicolon. A classic mistake. Huh. Is it using not it's ambiguous. Oh, I think it needs, maybe it needs parentheses. Okay. Yeah, we probably could do a whole workshop on joins alone. There is a lot of complexity once you have multiple tables and you nest joins and so on. I don't know, Clay, if you have any anecdotes from practice about joins.
Not really. I think it can be useful not just for obviously putting tables together, but also seeing which values occur in multiple tables. So yeah, does that make sense? But in this case, we're just using them to put together.
But the most common ones, I think, are the inner join and the left join.
Yeah, absolutely. There occasionally you can see, I think they call them full outer joins, which is where you take all of the values from table A and all of the values from table B. But I don't see those used very often.
Oh, there's a question about. So we want the plot ID and the genus, and we need to specify from which table we get it. We create an alias for the number of individuals. So here, from specifies the one table that's in the figure. It was table A, and to get this, we join with table B. So that's the species table here. So one table is joined with another using one value as a key, and we see in the structure that we need this to be present in both tables. So in group by is quite generic in the sense that it then can take multiple columns from different tables to use for groupings. Order by is only about the ordering itself. I don't know if it helps clarify. This is the syntax defined by SQL to join two tables or more. It's possible to nest joins, but we're not going to go there. Okay, in the interest of time, I would suggest we leave it at this, and there are a few extra exercises you could check out later in your own time. And feel free to reach out and get in touch if you've got any questions. I'm happy to answer emails. So I'll drop my email into the chat. Also into the shared document. So feel free to reach out if you try to apply things to your own data and you encounter any issues. So for now, I'll stop sharing this screen and we'll switch back to RStudio. Okay, I hope you can see my screen. So we will need packages called dplyr and ARCHER2. So you might need to install them if you haven't done so already. And if you have, then we can load those. One quick mention about another package that's useful, it's called DevTools. This allows to install things directly from GitHub. And then we'll work with the files portal memos SQLite, and we should have it in our data directory, but you can also download it using this command. I'll copy this into the shared doc. So the idea is that from inside R, we can use the library functions to connect to database and then get response of the queries into data frame to work with it in what I find is more convenient way. We're in the shared doc at line 895. So let's have a poll. Yeah, add a plus if you've got the libraries loaded, and you can find this SQLite file. So we will connect to file database, but it's also possible to create a remote network connection to a server, to a database server, using ARCHER2 or dbplyr. So let's open a connection to database. We can do it using a function, using this kind of syntax where dbi is like a namespace that so this as part of database interface, we use the function database or dbconnect, and we specify that we'll be using an SQLite database, which is defined as part of the SQLite package. So you notice that's the name here we're using. And this double colon notation means we use the function that belongs to that package. And what else we need? We need a path to the data. So for me, it's under data raw. Oh, sorry, no, for me it's under data. But if you use the download notation like this, it would be in data raw. Oh, let's download this anyway. Yeah. So we need to point to the database file. And if there was no error, we can see we have opened the connection. So it doesn't load the data just now. It instructs R to connect to the database first. We can then inspect the database structure. check that I loaded the libraries. Okay, so I was missing this function that belongs to dbply. So this is a database connection, and it says there's got some tables in there. Okay, let's see in the plot. In the poll, sorry, whether you got to the stage. So we got the libraries, we got the database connection. And what we could do next is to then use SQL syntax to query the table. So this way, if you've got someone gave you an SQL syntax query, you could use that using the following notation. So TBL mammals. So this we need to specify the database connection. Using tab completion is better to avoid typos. And then we specify the query as a string, and we can use our keywords that we now know. Select year, species ID, plot ID, from service, and we'll get the result a table, and we could save it into date frame, for example, or work with this. But we would prefer to use the dply syntax we learned yesterday. So we still need the table first, but then we can work so this is shorthand syntax for getting the whole service table. We can see it appeared here, and we can check its class. So we see this is something multifaceted. So it's a table that is can act as a SQL connection, as a table, and something that is lazy. We'll briefly speak about that in a moment. But for now, we can use also the pipe notation to select from the table. And you could see how it's very similar to SQL notation, but now we're working with type-diverse verbs. Maybe we can view this. So let's see. Or at least we should be able to select first.
I think it's a typo in the species ID.
Yeah. Okay, so it's still a database connection. What do we get? So it's not exactly as a data frame, but we can apply the verbs to work with it. What's a good way to view it? Yeah, so RStudio still knows how to print like a preview, like a header of this. So another way to inspect this could be to inspect the table itself, something like this. So we can also see the dimensions. We asked for 10 rows, and there are 9 columns in the table. But if we apply something like n row to surveys, we'll get odd behavior because it's not exactly a data frame, but the database connections, and we might get nothing if a connection fails or something like this. So it's n row function is not defined on this SQL connection objects. So it highlights the difference between dplyr using on datasets that are already in memory that we, for example, read with read CSV in the database. So to talk to a database, R needs to translate R code into SQL queries, send it to the database, and translate the response into R's data frame again. Sorry. So there is a function to inspect the query. So this way we can check, what's happening to the database. So you can see that n equals 10 translates into limit 10. And dplyr is designed to translate many R expressions using select and filter into SQL statements. So for instance, if we go back to select and filter that we had seen in the previous days, for instance, filter weight that is smaller than 5, and then select species ID, sex and weight. Mistyping constantly. So to run Control R or Command R. Okay, let's code result to see what happens if we save it. It still is not looking like easy to inspect data frame here. So let's talk about laziness first, because there's this behavior that a database will give you only a chunk of data until you need it. So you sort of post the request, and then the database might take some time to reply. So when working with the database, dplyr will not pull data ahead of time. So you need to explicitly ask for it. And it will delay to the last possible moment this kind of sending behavior. So if we've got this result part, it sort of creates the connection, but we haven't yet requested anything. We haven't requested any values, so this means there is the connection to the database that's ready to send the data, but it hasn't been sent yet. So it sent like a sort of like a header. So we need to, let's try. Look at some, I don't know, a row of the result. Huh, 1 second. Okay, so we need to explicitly call one thing. That's what I forgot. Sorry. We need to also collect. So this is where we say, actually send everything to us. Okay. So this is kind of a subtlety when working with this database connection objects. So now we see we did get the values, and we can inspect them. Okay, I was using the wrong row, so without the collect, it's a list, and then if we say give me result 15, this should then fetch it. I thought that would. Okay. Maybe assign it to something else. Okay.
Do you need to rerun your results action?
I think that's the collect part that actually forces it to send. So I must say I'm not familiar with this myself. So I should not try to freestyle this too much. Let me see. Go back to the material. So we need the collect to fetch it, and then you could see that it changed from the kind of database connection object to actual table that we can work with as usual. Yeah, so don't forget the collect part. That's the main message. Okay, we will here. I'll copy this over to the shared document. Okay, let's have another example. We can have a look at the plots. And we've got also plot ID in the surveys. So we could use join here as well. And we'll need collect in the end. One second. I'm trying to find the figure. There is a figure showing this diagrammatically, but it's. I'll stop sharing this for a second. Let's go to the browser. Okay, we're here. Hope you can see the browser. So there is yeah, kind of different view, so slightly more concrete than the Venn diagram. So if we've got two tables, we've got an ID. This will be the key on which we can join. So we can create an inner join, and you could see it's like an intersection of tables. It goes through all records and looks, is there in the second table the same ID as in the first? If not, then this will not be included. This is here, it's matched by the ID, so this will be included, and we get both the values for both columns. I hope it helps sort of visualize this. Inner join, it's like an intersection. Remember, we had this Venn diagram with the yellow in the middle. And left join, it will also include everything that's in the first table, but then some rows might have a missing value now for what's not in the second table. However, you can see also that values that have no corresponding ID in the first table will be excluded. So we see in the second table there is a ID 4 has a value, but we can see there is no record in the left joined result for that row with that ID that has no matching ID in the first table, if that makes sense. Any questions about this part? So tidyverse join page. It's got some more examples. I was hoping it will have a different graphical representations. So, I've come across a good representation somewhere, but I couldn't find it anymore. Maybe it's in the. Let me quickly check. Maybe it's in one of the cheat sheets. You know. So dplyr has a cheat sheet describing data transformation. Yes, so if you find the cheat sheet on data transformation we've mentioned yesterday, it's got slightly different description of all the other joins, like right join, full join, anti-join, and there's the whole host of them. But let's stick with this most common ones, inner join and the left one. So I'll share back the other screen. to finish this example, let's actually, join, write to join here. So we can filter plot ID to have only ones with the plot ID 1. And try join the surveys. And we need this collect with filter. Did I forget to load some library? I don't know. So we want, but I had deploy already loaded, so I don't think that's that. Plots. Go. Yeah. Okay, we've got some result. So we could see we got all values. If we forget the collect, we'll get this question marks. So usually it's only like 10 first rows or something like this. Okay. So we've got some time left. What would you prefer to practice in the remaining time? So we could either look at some other material or go back to the SQL syntax or anything else really. Do another join. Yeah, it's been a lot of information. Today, again, a new thing. One programming language yesterday, one programming language today. So I'd encourage you to try apply it to your own research situation. Maybe you've got a database, you can try connect to it. Okay, there's one thing we could do. There are no any particular requests.
We have a request in the chat.
Oh, yeah, that's a good question. So let's have. So if we get okay, we've got plots. If we store them, sorry. something like this. So we should have the data available now. And we could use this as input for ggplot. So yeah, let's do this as an exercise. So this also can behave now as a data frame. This means it should be possible to call ggplot and specify that as in data input. And then any suggestions? What should we plot here? Using geom. So we've got the data, we've got the statics mapping. So that we've got only plot ID 1 here, so it's okay. So for instance, we could, yeah, there's suggestions to plot weight over time. So if we've got maybe year and weight, and then let's have something like color, maybe species ID. Does it make sense to have point? Let's try point first, see just if something plots. Ggplot. Does one give on point on those? Maybe line. So it's just some missing values. And now, yeah, it doesn't look so meaningful in this style, but at least we've got some data out of the database. So it seems like there is still some, yeah, some grouping we need to do to make it. But could we still get points instead? Yeah, this also shows that not every geom is suitable for every data set. We might also work with, yeah, look at the structure of the data frame to fix, might need to switch from text to factors for some of the columns. Yeah, so something this is still used as a character. We would need to turn it into a fact to be able to properly group on it for faceting, let's say. But that's roughly the steps. So we connect to the database. Then we send a query, and we need to collect the results explicitly. This is to get around this laziness. Laziness is for efficiency reasons, so we don't fetch the whole database if we need only like a small subset. And once we've got the regular data frame, we can yeah, plot it or analyze it. Okay, let's see. got, let's say, 5 minutes. I would also keep few minutes left for the post-workshop survey. Let's do this first, and then we can do the extra exercises. I'll post this. Okay, let's do feedback first, and then if we've got some more time, I can stick around for a bit longer, and we could play around with the calculations. So let's do 2x2 feedback for this the whole workshop. So let's split this into presentation and content. But before, even more important is the post-workshop survey. So this is all the feedback is from line 943 in the doc. So spend a couple of minutes on the post-workshop survey first. This goes to the Carpentries and helps Carpentries improve or track all the workshops and so on. And the 2x2 feedback is for the session itself, so mainly for me. So and then we can have this rubrics of improve and keep again as last time, as we did 1x1 feedback. So yeah, if we use boxplot, probably we'll get some sort of summary statistic. Maybe not use the color, so we just keep average weight for all species. This will be the bar. Oops, no. Okay, group. Instead of color, can I group by? There was a fat year in the end of the 90s. I wonder what happened there. Okay, Paul, if you need to leave, see you. Thanks for joining. And everyone else, yeah, please submit some feedback. And then I'll stop sharing this for now. So what I would like to suggest, if you've got some colleagues also in your department or at your university interested in this type of stuff, organize some informal get together and see if you can get some kind of coding club-like thing going. And I'm happy to answer any questions that come up over the next few weeks. Feel free to email me, and we can also arrange perhaps a session, kind of a bring your own data session, if you're interested in that. So that we work instead of on the prepared survey CSV file on data that maybe not as clean, and then see how it goes. Yeah, let me know if you're interested in this type of stuff.